Hello and good morning. In this exercise we want to do two examples in differentiation. One with a fairly surprising result. And the first one is to differentiate y equals log to base x of 5 with respect to x. We first rewrite the right hand side as y equals log to base e5 over log to base ex. That's just using some basic results from logarithmic theory. Or again as y equals log to base e5 bracket log to base ex to the power minus 1. That makes the differentiation quite straightforward. So we have dy dx then equals the constant log to base e5, and then differentiating the logarithm part, that would be minus 1 log to base ex to the power minus 2 times the differential of log to base ex, which is 1 over x. And that quite easily comes down to minus log to base e5 all over x times log to base ex all squared. That finishes the first part. The second one is to find dy dx when y equals the inverse tan of sine x minus cos x over sine x plus cos x. Now I found this more easy to do if we transform the argument a little bit by dividing the numerator and denominator by the cosine of x, which will give us y equals tan inverse x of tan x minus 1 over tan x plus 1. And then write that as tan inverse theta minus 1 over theta plus 1 by letting theta equals tan x. And so differentiating with respect to theta, we will get sec squared y dy d theta equals, and now using the quotient rule for differentiation, we have on the numerator theta plus 1 times 1 minus theta minus 1 times 1, which is over theta plus 1 squared, and then dy d theta, that quite easily boils down to 2 over theta plus 1 squared. And I've taken this, divided both sides by the sec squared y, which is 1 plus tan squared y. So we have dy d theta equals 2 over theta plus 1 squared bracket 1 plus theta minus 1 squared over theta plus 1 squared. Multiplying out, we get 2 over theta plus 1 squared plus theta minus 1 squared. And then, further simplifying, we get dy d theta equals 2 over 2 theta squared plus 2, which equals 1 over theta squared plus 1. Now, we want to find dy dx. So we're going to use the chain rule here. Dy dx equals dy d theta times d theta dx. Well, dy d theta we've already found as 1 over theta squared plus 1. And we want to find what d theta dx is. Well, theta is tan of x, so d theta dx is 1 plus tan squared x, which of course then is just 1 plus theta squared. So we have 1 over 1 plus theta squared times 1 plus theta squared, which of course is just 1. I have to say that result surprised me when I first did it, but on further investigation, we just found the original function is in fact just x minus pi upon 4, measured in radians. Okay, so that explains that. Okay, well, that's it, and thanks very much for listening.